to them brothers and let them know
what goes on. Rolling stones in the rap game, not bragging. Lips bigger than Jagger, not sagging. Spell it backwards, I'ma leave it at that. That ain't got nothing to do with rap. Check the facts, expose those cats who pose as heroes, take advantage of blacks. Your government's gangsters, so cook the going on, so where y'all at? Fight the power, cause great responsibility. Who's stopping you from killing me? Disasters, fiascos, are looped by PE. If it's I instead of we believe in TV. Spreading riches, bitches, this new thing about snitches. Watch the masses move as the masses switches. System distant, but barely missed her. My sole intention to save my brothers and sisters. Get up!
Just like that.
Get up!
Just like that.
Get up!
Just like that.
Get up!
Just like that. Yeah, that's right, Chuck, man. That's what you gotta do. You got to tell them just like that. You know what I'm saying? Cause yo, man, let me tell you a little something, man. These brothers running around, hard-headed, they get a little jealous, you know what I'm saying? Just like that. You know, they try to bring you down with them. But yo, Chuck, you got to tell them just like that.
Screaming gangster 20 years later. Of course, endorsed while consciousness faded. New generations believe in them fables. Gangster boogie on 2 turntables. Show no love, so it's easy to hate it. Desecrated while the coroner waited. Any given Sunday, so where y'all rated? With slavery lynching and them drugs infiltrated. I'm like that doll Chucky, baby. Keep coming back to live love life like I'm crazy. Keep it moving, rising to the top.
I feel like I'm at the ocean.
Except here, the waves are man-made.
Hi, Jacob and Catherine. I'm Dr. Hoffman from Old Dominion University.
Hi. This is a great place to do research.
We've been wondering, what is a tide exactly?
A tide is the regular rise and fall of the surface of the ocean due to the gravitational force of the sun and the moon on our Earth.
We learned that gravity is a force that exists between all objects.
And it makes objects fall to Earth.
That's right. And the bigger the objects and the closer they are to one another, the stronger the gravitational attraction between them.
The sun is much larger than the Earth and the moon, but a lot farther away from the Earth than the moon. So which one causes the tides?
They both do, but the moon plays the bigger role, being about twice as strong as the sun. As the two of them create a gravitational force on the Earth's oceans, it causes the water to move upwards towards the sun and the moon.
And the Earth's gravity holds the water down.
Right, but the tidal forces pull water sideways along the surface of the Earth, and this tug-of-war creates a bulge in the surface of the ocean.
If the moon's influence is stronger than the sun's, then is the bulge bigger beneath the moon?
Yes, and due to the rotational motion of the Earth-Moon-Sun system, there is also a bulge on the opposite side of the Earth away from the sun and the moon. These bulges of water are large waves that we call high tides.
So if the water bulges on opposite sides, then it must draw water away from the area between the bulges.
Very good, and that is where low tides occur.
How often do we have high and low tides?
Many coastal locations, such as the Atlantic and Pacific coast, experience 2 high and 2 low tides each day. But some areas, such as the Gulf of Mexico, only have 1 of each.
Do the tides in a particular place always occur at the same time?
No, but the answer is a little bit complicated. On average, high tides occur every 12 hours and 24 minutes. The Earth spins on its axis every 24 hours, so if you divide 24 by 2, you get 12. The extra 24 minutes is because of the moon's orbit about the Earth.
Would high tides help bring objects floating in the water onto the shore?
Tides do not typically have much of a role in transporting objects in the ocean. You can think of tides as a big sloshing motion where objects go as far in one direction as in the other. Here, let's check it out.
That was cool. But what about the waves?
Jacob, can you get in the pool?
Can I?
See the waves around Jacob? They look like they're moving the water forward, but actually they aren't.
How is it that I stay in the same place?
Each particle of water in a wave moves around in a circle. Energy moves forward while water particles remain in the same place, so an object floating on the water will rise and fall as the wave passes, but the object will not move forward.
I think we definitely need more research about waves.
Me too. Thanks, Dr. Hoffman.
You're welcome. Enjoy the wave pool.
You better stop researching the waves if you want to get there on time. Bianca does not like to be late.
personality made her an American and a world hero. The irony of it is when she was once given an award for freeing 500 slaves, she said, "I could have freed more if I could have only convinced them they were slaves." She changed the minds of a lot of American blacks, and she changed American history with the Underground Railroad.
In this video tutorial, we're going to look at adding fractions with unlike denominators. For 1/2 and 2/5, we could see that the denominators 2 and 5 are different. Our job is to make them the same. To do this, we use the LCD, or least common denominator method. It's also called the LCM, or least common multiple. So once again, we need to find an LCD, or least common denominator, for 2 and 5. The first thing we do is list the first 4 or 5 multiples for 2. Next, we list the first 4 or 5 multiples for 5. Once we do this, we look for common multiples. In this case, 10 would be a common multiple. Since it's also the least common multiple, 10 will be our LCD. If you couldn't find any common multiples, you'd keep multiplying out until you get a common multiple. Once we have our LCD, we can go ahead and make it the denominator for both fractions. Next, we take the 10 divided by the 2 to get 5. Take that 5, multiply it by 1 to get 5, and that will become our numerator for the top fraction. On the bottom, we take 10 divided by 5 to get 2. Take that 2, multiply it by 2 to get 4, and that will be our numerator for the bottom fraction. Now all we do is add our numerators together to get 9/10, which is our final answer since it cannot be reduced any further. Now it's your turn to practice what you just learned. You can pause to work out the problem, then press play to get the answer. We're going to do 2/3 plus 1/6. Go ahead and try to work it out. If you did it correctly, you should have got an LCD of 6. We put 6 as the denominator for both fractions. For the top fraction, we take 6 divided by 3 to get 2. We take that 2, multiply it by the 2 to get 4. We take 6 divided by 6 to get 1. Take that 1, multiply it by 1 to get 1. Now all we do is add our numerators, 4 and 1, to get 5/6, which is our final answer. If you got this correct, give yourself a hand.
Set.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, and justice for all. Honor the Texas flag. I pledge allegiance to thee, Texas, one state under God, one